By just keeping the sum of the bytes that is sent, or the low bits of that sum, we call that making a packet with a checksum. Right? There's a sum attached to the packet. It's just one extra number in addition to all the other things we're being sent, so it makes the packet a little bigger. And now on the receiving side, after we receive a packet, we can check whether it's obviously corrupt or not. We just check whether the checksum inside of that packet matches the packet overall. And only if it's not corrupt do we extract the message from that packet and send it off to the receiving client. But now, what if it is corrupt? According to this state machine, we just stay in the wait per packet world because we got a corrupt packet. We just ignore it, in other words. So a receiver over here needs to get some information about whether the packet was received correctly or not. And if you're talking to a clerk at a store, you get that confirmation back from them directly. And so the similar idea needs to happen here. The receiving side, after it sends a packet, needs to wait to hear back from the other end whether it got there without being corrupted. You can see how this is also going to help when we start talking about lost packets, but for now we're just waiting to hear whether that packet got there uncorrupted or not. So the sending side is going to transition from waiting for the application to waiting for an ACK. That is an acknowledgement from the receiving side. When it does get that message back, then it can know that the packet got there successfully, and it can go back to waiting for the application to send more data. The way it gets that information from the receiving side is that the receiving side will send a packet back to the sending side. So here again, this is why the sending side at the transport layer needs to use both send and receive at the unreliable lower layer that it's building on. But when it gets that packet back, and it does seem to be an acknowledgement packet, then the sender will go back into wait for application. So where does this packet come from? It comes from the sender side, which now, after it is decided that it has a non-corrupt packet and it's extracted it, then it's going to send back an acknowledgement saying that that packet was good. So if everything is working properly and there's no corruption, then the sender will go between these two states, and the receiver will stay in the state where it gets a packet and then explains that it got a good one. What if it got a bad one, though? Then in that case, when it receives a packet and the packet is corrupt instead of not corrupt, we have a different action. The arrow is still going to go back to the same state, but we're going to send to the receiver a packet that says a NACK, or negative acknowledgement, saying I did get a packet, but it was a corrupt packet. Because that's the other possibility on the sender side. It's waiting for an acknowledgement that the packet is good, but if it gets an acknowledgement that the packet is bad, then it's going to stay in the wait for acknowledgement state after retrying the packet. So here is our first case of a retry. We sent a packet. The other side says, no, it seems to be corrupt. Try again. We send it. Eventually, we expect, we will get an acknowledgement back that the packet was okay and go back to waiting for the application to send more data.